So we can start now.
Mhm.
Welcome back, everyone. I hope you all had a refreshing break and are ready to dive into exciting part of our workshop. Now that we are all settled, it's time to begin our first session. I would be delighted to welcome Counselor IEEE Student Branch and Faculty Advisor IEEE Power Electronics Society Student Branch Chapter, Convener of Robotics Workshop, Professor Dr. Sanjiv Kumar Sir. He is a senior member in IEEE and fellow IETE. He did his MTech and PhD from Indian Institute of Technology, Roorkee. Currently, he is the coordinator of HRD Cell and Associate Dean of School of Engineering. He was associate professor in Electrical Engineering Department from 2019 to 2023, and now he is a professor in Electrical Engineering Department. Now I would like to call Sanjeev sir to start his session.
Thank you, Unnati. Good morning to all of you. As the first talk is on the topic Basic of Electronics, Microprocessor and Microcontroller. It is advised to all participants, please turn off your mic during the session. In case if you have any doubt or query, you can put it in the chat box, or neither will take care of your queries. And in the end of the session, they will put this in front of me, right? So this talk is basically give you an idea about what electronics exactly it is and what are the difference. First of all, what is the microprocessor, what is microcontroller, and how a microcontroller is different than the microprocessor, and how these things are related to our workshop. You will get an idea of all this, as so many students are from various streams like food technology, paint, plastic, as well as from the first year from various engineering college and HBTU as well. So in this lecture, I'll start from very basic fundamentals and then get you involved in the microprocessor and microcontroller. So my presentation contains brief about electronics components, microprocessor, microcontroller, and conclusions, which we will draw after this talk. Am I audible, Adit Keshwaji? My voice is clear? Can anybody confirm?
Yes, sir.
Yes,
Otherwise,
Max is
sir.
clear.
it is okay. Fine, fine. Fine.
Yes,
Thank
sir.
you. Thank you. Thank you very much. And it looks that you all are in the Jagrat position, means active position. And see, we all are from the electrical engineering background. There is a phenomena of resonance, and resonance happen when source and load impedance are same. And in case of AC, if it has to be conjugate of each other, then only maximum power is transferred. So, if we talk about this class, and who is talking? Who is talking? Some noise is coming. I think Unnati Anand mic is on. Just check, please. Okay, fine. Now come to the main course, that is electronics component. In this talk, we are specifically talk about the components which are going to be used in our workshop, like register, very fundamental and basic components, like registers, capacitor, diode, transistor. I am not going to talk about the higher end like IGBT, MOSFET, power electronics, ICs, and all those things. We will talk about very, very fundamental components related to our workshop. The very first component is register. These registers, everybody knows this because we have studied in 12th standard. We know a register, but just to start, just you can say the warm up exercise. I am taking this included this in our talk. So registers are used to limit the current or divide the voltage. How this register limit the current and divide the voltage, this we will see in coming slides. And of course, whenever a current pass through a register, they produce heat by I square R losses. Right? So these registers are used when we wish to reduce the value of current or when we wish to divide the voltage, then only we use these resistors, right? And it is simple two terminal non-polarized device, means there is no concept of polarity. You can use it either way at any end. You can see it is the resistance. It is a two terminal device. The symbolic representation is in front of your screen and its unit is ohm. And if we talk about the higher value, it could be kilo ohm, denoted as K and symbol ohm. Further going to higher range, it could be mega ohm. M means 10 to the power 6 and ohm. And this is the barcode. If we tomorrow you will get two three board like Bluetooth module. You will get motor H bridge and all. Arduino board, there you will find their resistance would be there. And in the market, when you go to purchase, there is a color coding in the resistance. I hope you all knows this, but just for example, I am demonstrating that there are color coding. For example, you can see here the is first code is red one, and the first digit value red color is 2. Then we have purple. The value of purple violet is the 7, second digit. Then third digit is yellow, and the value of yellow is 4. So these three band are the digit. It shows the value 274. Then the multiplier. For black, the first one is 0, 10 to the power 0. Then 10 to the power 1 for brown, 10 to the power 2 for red, so on and so forth. As the fourth bar is black, the value is 0, so 10 to the power 0 is 1. The value of the resistance is come out to be 274 ohm, 274 ohm, right? And then it is not possible to have perfect value. There must be some tolerance. The tolerance limit is given by the next color band, that is red. It could be any color. For example, in this resistance, it is red. So you can see it is the value of 2, means there would be percentage tolerance is plus minus 2%. And then we have the temperature coefficient. So using this, you can come to know what the value of the particular resistance available in the market. Now, moving further, as I said, it is used to divide the current. How can we divide the current? We can divide the current when we use resistance in parallel. You can notice that just me this is R1, this is R2. When the current flows from here, let us say it is 10 ampere. And if R1 is equal to 5 ohm and R2 is equal to also 5 ohm, then half of the current, that means 5 ampere would flow here and 5 ampere would flow here. If we change the value, if we make it 10 ohm and this is still 5 ohm, in that case, this 10 ampere is divided in the ratio of these resistance. This would produce 2 times great resistance than this. So two third, two-third of the current would flow here and one third one-third of the current would flow here. So this is the value of I and multiplied by resistance 10. So it is come out to be 100 by 3. That is the voltage. 100 by 3 volt. And if you look at here, it is come out to be 2 by 3 into 10 into 5 ohm. So it is also come out to be 100 by 3 volt. As these 2 points are in parallel, so voltage must be same. So you can notice if the value of resistance increase, current decreases. Current decreases. In that way, current is divided by using resistance in parallel. I know most of the student knows this concept, but just a beginning, I am just showing for those who have recently joined the engineering, means our first year student, and as this is the first semester, some are studying electrical engineering in the odd semester, and some will study electronics. In next semester, they'll swap, means those who are studying electrical engineering in this semester, they will study electronics in another, like that. So for those, I am just included all this thing. Now, how a resistance could divide uh, this, voltage. So you can see for that we have connected 3 resistors in series. Let us say 15 volt is applied. 15 volt is applied to these resistors. 15-volt battery. And if R1 is equal to 5, R2 is also 5, and this is also 5. So 1 ampere current would flow from here. I is equal to 1. So 5 into 1 equal to 5 volt. 5 into 1 equal to 5 volt. 5 into 1 equal to 5 volt. Total 15 volt divided into 3 resistance of equal value. If you change the value of resistance, then of course voltage would be different because current is flowing in all three resistors. If you change the value of resistance, the potential drop across that particular resistor would get changed. Right? Now, the next component is capacitor. The next component is capacitor. Again, it is a two-terminal device. It stores the energy in the form of charge. Right? And the capacitance means how much farad or microfarad it is. The value of capacitance is the measure of ability to store charge. How much charge can a capacitor hold? The max, the value of charge hold by this, its ability to hold is denoted by the its capacitance value, right? A large capacitor means it can store more charges, right? And I suggest Adit Keshwaji bring the presentation. If you put me as well as my presentation pin, then in that case, uh, size of the presentation would be screen would be less. So it would be good. I think now only presentation is pinned, so everyone can see. Now, it is measured in the unit, its unit is farad, but microfarad, millifarad, depending upon the or picofarad, because 1 farad, the size of 1 farad capacitor is quite high as the radius of the earth, which we have already known. So it is denoted as microfarad or sometimes picofarad means 10 to the power minus 12. In the market, you would have two type of capacitor, that is polarized and non-polarized. The first one is the polarized, means there is a positive plate and negative plate. And you can notice those who have ever take the capacitor in his or her hand, they know that the negative terminal is smaller as well as a black uh, line is there with negative symbol. So this terminal has to be connected with the negative polarity, whereas this long terminal has to be connected at the positive polarity. As in case of AC, as in case of AC, there is no concept of polarity. So these are non-polarized type. You can connect any terminal to either side. There is no question of this polarity, right? In the electronics, I'm telling you whatever I am teaching in this particular class, that is mainly related to your robotic circuit or basic electronic circuit, not in terms of electrical engineering, because the capacitor, higher voltage capacitor, voltage rating capacitor are also used in the power factor improvement or the reduce the ripple in the DC circuit. I am not talking about all those. I'm specifically talking about the small capacitor, electronic, the capacitor which are used in electronic circuit. These electronics circuit use, one of the uses in timer circuit. There is an IC 555 timer where we can have the frequency, various frequency of the timer, generate the pulse of various frequency depending upon the RC value. Then there we use the some sort of gang. Gang is the nothing but the parallel plate capacitor. We keep on changing the value of we rotating the uh, gang and knob, and the value of the capacitance get changed. So we will have variable capacitance. You might notice whenever we are use radio, then there is one knob for tuning the particular station. There use the parallel capacitor of this GAN type concept. Means when we rotate this, that area interfacing to each other keep on changing, and the value of capacitors get changed. They are also used to clipper and clamper circuit, means clamping at particular voltage and all along with the zener, right? They also used to provide flashlight, which we are using this mobile or our camera, because that capacitor can be discharged suddenly and quickly charged. So there, to generate this huge amount of voltage that can create flashlight, we also use the capacitor. And these are also used to reduce the ripple in the rectifier circuit. So capacitor are having use there. The next component is diode. Diode is again a two-terminal device which allow the flow of current in unidirectional. Current can flow only from anode to cathode. Current can flow only from anode to cathode. The symbolic representation is this, where you can see this arrow denotes the direction of current. It can flow from anode to cathode, right? And symbol, these are the pictures which are available in the market. For example, this picture is IN4007, which is a diode, and this is the, you can see this gray color. This gray color is the negative terminal. A stand for anode and it is positive. K stand for cathode and it is negative. Whenever anode to cathode voltage is positive, then only this diode can conduct. It can conduct means it act as a short circuit. It act as a short circuit. Whenever this anode minus cathode voltage is negative, it will act as open circuit. Right? I'm not going to in depth of this, because see, whenever this conduct, ideal diode is drop voltage is zero. That means the voltage drop across anode to cathode is zero in case of ideal diode. But in practical diode, either German or silicon, there is German, it is somewhere around of zero point 0.3, and in the silicon it is somewhere around zero point 0.7. Right? This I have already discussed. This is another type of diode. It is light emitting diode. In your Arduino board, you will notice whenever this Arduino board is connected to the PC, there is light blinks. So that is nothing. It is also a type of diode. It is light emitting diode. Whenever it conducts, base of NPN is high, it is connected to high logic means plus 5 volt, then it would short circuit and switches on and it will start conducting. And when it is low, means when when it is low, it will act as open circuit. It will act as open circuit, right? So it will act as off. Whereas on the contrary, this PNP act as inverted switch. Means whenever the logic is high, means whenever you apply plus 5 voltage at the base, this switch, this transistor would get off. Means it won't conduct. It would not conduct. And when this voltage is low, it will start conducting. So depending upon your requirement, your logic, you can use either NPN or PNP transistor. Practical use are, it could be used as a switch, means on and off, right? It could be also used as an amplifier. It could also use as to realize logic gates like AND or NOR and so on and so forth. So these basic electronics components you are going to see in the upcoming, uh, not upcoming, in fact tomorrow, when you will get the uh, kits for making your own robots, right? The next thing is motor. Motors, we are using four motors to make our rover. So what type of motor that you should know? Once you know the type of motor and specialty of those motors, then only you can use it properly depending upon the applications. Right? So the type of motors are, it could be AC motor, it could be DC motor, it could be geared motor, could be step motor, it could be servo motor, it could be switch relaxed motor. See, there are so many type of motor. I have included those motor which are specifically used for your robotics purpose. Right? We talk about the AC motors. They are, you are well known of this. For example, the fan, ceiling fan. It is using single phase AC induction motor. Your atta chakki, they are using three-phase induction motor. So AC motors, induction motors are used like water pump, fan, table, so on and so forth. And you might notice this type of commercial motor in your home or uh, any hardware shop or somewhere here or there. Now, second category is DC motor. As name suggests, the supply of this motor is a DC, right? AC motor, what AC motor does? It take AC power and convert into rotational power or mechanical power. Whereas DC motor, what it does? It take DC power and convert it into rotational motion. So in robotic application, these DC motors are preferred over AC motors. The reason is our circuit is DC, Arduino board or Arduino board, and this your Bluetooth module, or these are the DC. So it is good to have same type of supply for board as well as for motor. That is why preferred. It is preferred to have DC motor rather than to have AC motor. Don't get confused. I am the person from electrical engineering, but at present I am specifically taking all the thing in context of the electronics and especially used in the robotics field. Right? So you don't think DC motor is like a small motor. It could be huge motor which is used in our field like traction and all. Right? This is the small 12-volt motor which is used in the previous days when there is audio cassette player there to rotate that cassettes. This type of motors are used, and still you can use it today's word as well by substituting the gear and all. You can use depending upon your application. So next one is DC geared motor. It is same as the DC motor, but it is also having external gear arrangement. Gear are nothing. They are simple. Okay, come the. I mean, I'll show you what the gear and all. See, in your bicycle, you might notice there is a system of gear because when you do paddling, there is a big flywheel and a chain is there. A small flywheel is connected at the back of the your wheel, and when you paddle, the back wheel rotates, so your bicycle rotate like in your bike. This bike, you will get the energy from the petrol fuel. Right? In bicycle, you will put efforts to move that bicycle using the gear system and all. Whenever we want to change the value of torque or speed, we use gear, right? So these motors are very much used in the robotics. Like for a rover, our rover that has to be moved on the four wheel, and sometimes there is slope. So on rising slope, you have to have high torque. To create high torque, we use the gear. I'll come to that probably in the last of this lecture or my next lecture. So gear motor are used very much used in the field of robotics. Here you can see the same DC motor is having external gear. The same DC motor having external gear. This is the DC motor and this is the gear system connected with this. Connected with this. Right? Next is stepper motor. As name suggests, it move in step, small step. It is not keep on continuously rotating. It take the signal and move in step. That is why it is called the stepper motor. It could be unipolar or it could be bipolar. Unipolar means it will rotate, it will move certain step in the clockwise or anti-clockwise direction, not in both the direction, only in one direction. If it is bipolar, it can move clockwise as well as anti-clockwise, both the direction. Right? This is the practical, commercial available stepper motor picture, and you can see how it moves. Whenever your first coil is energized, you can see how it is moving. First one is energized, then two, then three, then four. So it moves in step, small step it is moving. There are four poles. So you can see when first pole is energized, it is moving in that direction, means clockwise, then second, then third, and then fourth, and repeat 1 0 0 0. This is the logical signal which you have to provide to the uh, your motor module, driver module, so that these signals are coming from the Arduino board, and this signal is to be provided to the motor board, so that excitation of the coil could be happen and motor start rotating. Here it is very much clear. You can see there are four coils, one, two, three, and four. You energize this one, so motor start rotating. Then you energize this one. One is off. This two is on. One, three, and four are off. You can correlate this thing with this, the logics, right? This is for coil 1, coil 2, coil 3, and coil 4. Here you can see. Here you can see. 1, 2, rest are 0. Off means 0, on means 1, 3, and 4. Then again 5. 5 means cycle repeat itself. There are only 4 poles. So 1, 2, 3, 4. 5 is equal to 1, means 1 is repeated. 1, 2, 3, 4, 1. 1, 2, 3, 4, 1, and so on and so forth. In that way, it is rotated. If it is double coil excitation, then two coils at a time, means first and two which are in diagonal. So resultant would be 45 degree of resultant torque would be at the try to align the magnet of the rotor in the 45 direction of the coil. So at a time, two coil has to be energized. One, two, two, three, three, four, and therefore 1, so on and so forth, right? Now next is servo motor. Next is servo motor. Whenever we require precise movement, Harsh Yadav has raised the hand. Harsh, do you have any problem? Organizer take care of this Means whenever any student raise hand or put any comment, you just address him, or if you wish, I can start answering to them right now. Right? It is up to you in what way you wish to conduct this session. Fine. So it is the most powerful variants of motor, and AC as well as DC servo motor, both type of motors are available. Right? This is a small servo motor. Whenever we require precise movement, precise motion, then we use the servo motor. It is costly one because it uses encoder. Encoder are the means it generates pulse per minute, ppm, and depending upon the number of pulse, it can calculate the position of the shaft. Right? So very precise, very precise. So servo mechanism is there for error sensing and the correct the performance of mechanism. As I said, these are where used where very precise movement is required. So there is servo mechanism. Now the question is which one we should prefer, servo motor or the stepper motor. Both are having their own advantage and disadvantage. The advantage of stepper motor are they are very much stable and they can derive a wide range of fractional and inertial load. They require no feedback. You just keep on turning on and off of the excitation. Right? They are already having their position transducer. Right? Because there are four coil and the magnet rotation of magnet from N to S is going on in the it's how you energize the coils. So they are inbuilt inherent position transducer. Right? They are inexpensive related to the other motion control system. Not only this, they are plug and play. You just energize and start working on it. They are having long life because bearing are the only wear out mechanism and nothing else is required. And if the bearing get damaged or deteriorate, you can change the bearing. All right. So they are having very good torque handling capability, especially at a low speed. Right? Without any gear, without any gear, and they are little bit safer even if you do the overload, right? Whereas if you look at the servo motor, they are having their own advantage. They are having very high output power relative to the that size. If you compare the size of servo motor with others, the size of servo motor is quite small as compared to others of the same output power rating. That is the biggest advantage of the servo motor. They use the encoder. As I told you, encoders are used to get the feedback signal. They are two types, incremental as well as absolute encoder. We will uh, see the advantage of various encoder. I don't want to get in detail of that. However, in a single line, I would like to share that incremental encoder is required the referencing. Whenever power goes down, you have to reference it again. Means reference it for the positioning where exactly it is. Whereas in the absolute encoder, no referencing is required. Once you align, even if power goes, it will come to the its reference value automatically, right? So another advantage is it is very high efficiency, and even if it could go up to 90% of the efficiency, it can have 90% efficiency at light load. It has high torque to inertia ratio. What is the advantage of having high torque to inertia ratio? Means if the motor is in a standstill position, you require very much torque to move this. it has that capability. It accelerates growth very fast, very rapidly. Means it can achieve very high speed within few seconds. That is the meaning of high inertia rotation. Now, the advantage is going on that is power. Power, it is the 2 to 3 times power. You can withdraw it from for a very short period. Not on the continuous basis, of course, but for a short period, you can have 2 to 3 times the rated power. Now, it can also handle 5 to 10 times the rated torque for the short period. You can see the capability of the servo motor, but at the same time, you have to pay the cost for all this advantage. It is up to you, my dear friends, which motor you wish to use. And the audibility quality is very, very uh, high speed. It is quite silent. No sound you will feel, or very little sound you would feel. Right? Now, if we talk about the disadvantage, stepper motor are having low efficiency. At the same time, torque is also drop when you increase the speed because the power is torque into speed. If you increase the speed, torque goes down. So only at the lower speed you can have high torque, but you can't have high torque at the high speed, right? No, there is no feedback so that you can measure whether it missed any step or not because there is no feedback mechanism available in the stepper motor. So that is the disadvantage of stepper motor. It is also having low torque to inertia. Arnav Sim is asking for some example. Yes, boss. On which topic you want to example, Mr. Arnav? Turn on your mic.
Yes, sir.
Yes, bacha.
Good morning, sir.
Very good morning, dear. Although Arnav, it would be great if you ask in the last of session because otherwise we are talking. You just tell me on which topic you want example.
Sir, I just wanted like a real life example where the servo and stepper motor can be
Because
utilized.
servo motor can be used in the robotics as well as in the induction heating machine. Whenever we wish to position, see in induction heating process, in all automobile industry, they are used to induction heating just to get extra strength on the wheel or the portion which are in contact of the metal. So there what they do, they are having one inductor. That inductor is positioned at particular place and using the inverter, they get heat by eddy current. And the moment it is heated, a quenching material is dropped. So positioning that inductor, servo motors are used. And if we talk about the stepper motor, your this robotic application where you want to move the in some short duration, then you can apply this number of step for this movement, this number of step for this movement. Yeah, these two are the example of servo as well as stepper motor. Right? Arnav, you are from which branch?
Sir, I am from the electronics engineering branch.
Great. Right? I hope I have cleared your doubt.
Yes, sir. Thank you, sir.
Welcome, dear. So the it is also very low output power as compared to its size and weight of other category. Right now, come to the servo motor. The disadvantages are that the complex as it requires encoder. As I told you, the referencing of the encoder is a tedious job. Means if you use incremental encoder, then you must have the correct positioning. Then only you can, if the reference value is not clear, then the other positioning would get different. That is why it requires a very complex process so that referencing has to be done properly. Then only it works Another problem is that its brushes were tear out within 2000 hours. And that time you have to have service. It means it might be possible you have to change the brushes, right? And the peak torque is also limited. It is only for the 1% of duty cycle. Means for the maximum torque duration which is available, the torque where maximum the duration during the time which during when the maximum torque is available, that is only the 1% of the duty cycle. Duty cycle is the ratio of on divided by the total time, is how much time the coil is energized. Alright? And if you keep on overloading, it would get damaged. If you keep on overloading, it would get damaged. Alright? It can take power supply current 10 times average to use peak torque. Right? You can imagine how much current it has to handle. Another disadvantage, it develops peak power at higher speed. So you must require some gear which can reduce the speed, because at peak power it is have high speed, and you want to use that much power but not at the high speed. You want at lower speed you should get that power. So for that purpose you must use the gear, some gear or ball screw type mechanism to have it. All right, it is a very poor motor cooling. So ventilation is to be required. Right. So this is all about resistor, capacitor, diode, transistor, and motors. Now, next component is microprocessor. We are doing the Google Meet. Everyone is using tablet, mobile, or laptop, and there a microprocessor is used. I would like to ask a question since Arnav is from electronics engineering stream. Which microprocessor at present you are using? Can you tell me? Arnav,
So
which
if
micro,
someone is, yes, sir, if someone is using a Windows laptop, so they might be using an Intel
right?
microprocessor.
Means, very good, bacha. Means Intel has captured 80 to 85% of the market. They are pioneer in the field of this microprocessor. So microprocessor is a clock-driven integrated circuit the, that contains the function of CPU, and it performs all arithmetic, logic, control, IO related operation, and it acts as a brain of your computer. As Arnav said, those who are using the Windows, they are using Intel. It is not like that. Whatever the operating system, whether the Windows or Linux or any operating system you are using, the microprocessor could be anyone. Like it could be Intel, it could be AMT, it could be Zilog, or any micro processor could use the operating system. Operating system is the software and microprocessor is the hardware. For example, we can't see our brain as having some weight, mass, volume, everything. But the information what brain is having, that is not having any mass or volume or anything. So those information is the software and our brain is the hardware. So microprocessor is the heart, you can say, of any computing system, right? So like in smartphones, cars, household appliances, everywhere microprocessor could be used. But microprocessor is a very, very big machine. Big machine in the sense its capability is huge. So it is not good for a small application you are using microprocessor. Then the concept of microcontroller comes. I'll come to those slides as well. Before going to detail, I would like to share the history of microprocessor. The very first microprocessor, why Intel is the pioneer? Because the very first microprocessor introduced by Intel is 4004. It was introduced in 1971. It was 4-bit microprocessor. It was 4-bit microprocessor. 4-bit microprocessor means it can 10 low, high, high, low. That is the bit. Right? It was the first commercial microprocessor. Then next is 8008. It came in 1972 by the Intel. It is the 8-bit processor, means it can process 8 bit at a time. It can process 8 bits at a time. Then next came in 1974. Again, it was from Intel and model name was 8080. Right? It was the 8-bit processor. It was the 8-bit processor, the first widely used microprocessor all throughout the world. For very fast processing. It contains 6,000 transistors. It contains 6,000 transistors. The transistor which I have told you in the beginning of the talk. Right? Now in 1976, Intel introduced a very wonderful processor which is 8085. In third year electrical and electronics student, I hope in our HBTU electrical student studied this processor in fifth semester. I hope either fourth or somewhere fourth or sixth electrical or electronics student or both, they studied the this processor. It is a 8085 8-bit processor and it introduced in 1976. It is with improved speed, low power consumption, and huge instructions are introduced. After this, 8088 also came, but I have not mentioned because the most popular one is 8085. Then they come up with 16-bit processor in 1978. They come up with 16-bit processor in 1978, which is known as 8086. So they are having 86 series architecture. Then 286, 386, all these processor came in 1982, then subsequently 1985, 386. It is a 32-bit processor. They have introduced the concept of virtual memory. Then Pentium series came in 1993 onwards, and Pentium Pro 2, 3, and P4 was the last processor of Pentium series. And then Core series is started in 2006. I have included this slide because this history is, you must know, being an electronics and electrical engineer, you would surprise that in Intel, if you do Google, 70-75% of the employees from electrical engineering background. Even though we think that, see, microprocessor is somewhat related to computer because it is used in the computer, so computer science stream student should know. But we are the creator of this microprocessor, which is the processing unit of any computer, laptop, or tablet, something like that, right? So you must understand all these things. And in this core series, core duo, core i3, 5, i7, i9, they are coming up till date, right? So now this I9 series and modern innovations, they also introduced the hyper-threading technology, turbo boost and large cache. Cache memory is the somewhat different memory. It keep on tracking the what type of uh, frequent files you used to browse. Then they store in the cache. You might notice in your mobile there is an option of clear cache. What clear this cache memory does? Whatever the screen, whatever the picture, or whatever the things which you use to frequent, microprocessor store those file in the cache memory. Right? So very costly, expensive memory. Then nowadays they are working on a Intel 10nm and 7nm process technology. In fact, it is shrinking into 15 nanometers to 7 nanometer for the better efficiency. All right, that much size is uh, compact. When the computer was invented, the size was quite large, but over a period of time, it is get reduced, and now it would become in the palm of your palm. The basic components of any microprocessor systems are uh, ALU, which is arithmetic logic unit, its control unit, which control its various type of action. It is having their own register, that bus interface unit, memory unit, clock generator, and instruction decoder. Basically, microprocessor, what it does, it take the instruction from the user and decode it, then take the decision upon the decoding results, and give the response after proper calculation, which has to be done in the ALU, arithmetic logic unit. All right. So, microprocessor is a clock-driven machine. Which take the instruction from the user, decode it, and give the result. Now, after microprocessor, what is microcontroller? My, see, in the microprocessor, you have one unit dedicated to your ALU. You have uh, this somebody is mentioning that thousand and lakhs of register and all. If you notice, yes, who has written one message? Please turn on your mic so that I can clear your doubt. Someone written message.
Yes, sir.
Unnat, yes, please, Saurabh.
Yes, sir.
Yes, Saurabh, tell
Sir,
me.
my doubt is that uh, microprocessor had both transistor as well as capacitors.
Thousand transistor capacitor register is having all. It is having all. See, transistor can't run without register. For biasing and all those things, the transistor must have register, right? And the numbers of value 6000, which I have told you, that was the in the beginning phase of the microprocessor. Nowadays, it is having thousand of register and this capacitor and the transistor in a single chip, right? It is not like that only transistor made this. Even there are so many flip flop. There are so many IC like 74LS373 gate IC, latch gate IC, right? There are trans
Oh,
receiver, there are clock generator, there are timer 8253, there are peripheral 8255, there are interrupt controller 827, and so many peripheral are interfaced with the microprocessor, right? So many things are there, beta. But it is very difficult. See, this is the entire big once subject is there, which our student used to study in fifth semester. And fortunately or unfortunately, I don't know, I am teaching the microprocessor since 17 years. So it is very difficult, beta, to complete basic electronics, microprocessor, and microcontroller within a short duration of 1.5 hour. Clear?
Yes, sir. Okay.
Fine. Saurabh, you have joined two places. Saurabh Gyani,
Yes.
you are from which institute?
Sir, from HBTU.
Okay, but logo is not from HBTU.
Sir. Sir, I am
It is from,
actually doing some other courses also.
okay. So it would be great if you put your picture or put the logo of your alma mater. In fact, where you are studying
So
as
I
well,
am
and this is
actually
not.
doing BS and research also in
Ah,
electronics.
yes, beta.
So I am also doing BS and research in electronics also. That's why I have put that.
Okay, fine. It is up to you. I have just noticed. So, in first place, it looks like IIT Roorkee logo. So I was very much happy that someone from IIT Roorkee has also joined. Right. Anyway, it is up to
Sir,
your
I am from
choice. What
IIT Madras.
you are from?
IIT Madras, sir.
You are from IIT Madras. Have you
Yes,
registered in
sir.
this workshop?
Yes, sir.
Oh, great. Unnati, do we have registration from IIT Madras?
So let me check once.
Because yeah,
Sir,
okay,
actually,
yes.
he's from HBTU, but he's doing something other course in IIT Madras.
Is
Dual
it
degree,
like
sir.
that?
Like,
Yes, sir.
Okay, we will talk. You will take care of him. We will talk about this after the session, right?
okay, sir, what is the name
Fine.
of that guy?
This Saurabh
Saurabh.
Gyani, some
Okay,
Saurabh
okay.
Gyani,
Okay, sir.
right? Okay. So this is now the microcontroller. This is the compact integrated circuit, and see, in the microprocessor we have separate block for memory, we have separate block for IOs. Means all are separate, not in a single chip. But in microcontroller, all are having a mounted on a single chip. That is the, you can say, big difference between the. I'll also explain the difference between the microprocessor and microcontroller in coming slide. But uh, on a large, you can differentiate these two by this. Again, it is also act as the brain of embedded system. Right? Like computer was the brain of microprocessor was the brain of computer, and it is the brain of embedded system, which is a very small in size chip. Right? It processes the information and gives the control output depending upon the decision taken by this on the basis of programming done by the user, right? It interface and communicate with other devices and sensor, and we are also using one microcontroller in our rows, right? Some popular microcontroller are 8 mega 328, ESP8266 and ESP32, like PIC and 8 mega 2560. I'll also try to, I hope I have included, and if time permit, I'll also give you detail of this microcontroller as well. The basic difference between the microprocessor and microcontroller are as follows. The microprocessor is the central processing unit, which I have already told you of any computer, and they are having different RAM, ROM, IO devices on different parts. These are not the part of the microprocessor. On the contrary, if we talk about the microcontroller, it is an integrated system. Means it is having its own CPU, it is having its own memory, RAM as well as ROM, random access as well as read-only memory both. And it also have IO peripheral on a single chip. All input, output, everything is on the single chip. So you can say this is the small mini microcomputer embedded on a single chip for specific function. For example, in your household, there is a washing machine. There is also microprocessor, but not the microprocessor because a small work it has to be done. It has to rotate the machine dryer. It has to wash and all those things, your clothes. So a dedicated chip, a microcontroller, a pre-programmed microcontroller is there in your washing machine, in your oven, and so on and so forth. Right? Others, this is the basic difference between the purpose. Now, if we talk about the architecture of the components, so I have told you that in the microcontroller, it has built-in IO peripheral, then in a single chip, whereas in microprocessor, these components are separated. If we talk about the application, these microprocessor are very high performance system because these are the general purpose microprocessor. It can compute very complex process. So in computer, laptop, smartphone, they are use this type of microprocessor. Servers, data loggers, those use microprocessor. DCS system, distributed control system, they are using microprocessor. Whereas if we talk about the application of microcontrollers, they are using embedded system where application is very specific. For example, our rover, its application is very simple. It has to be move forward, upward, and rotate. That's it, either clockwise or anti-clockwise. Very specific application. So microcontrollers are used where we need very specific application. I have already given you these examples: washing machine, microwave, automatic system, and IoT devices. Right? For home automation, you can use microcontroller. For lock your security system, for locking your door, you can use this microcontroller based system. Right? That would be discussed by Mr. Astos in his lecture on third day of this workshop. Now we talk about the processing power and efficiency. The microprocessor has a higher processing power. It can handle very complex tasks. You might heard about the Param computer, right? Which can uh, execute several thousand millions of instructions very fast, right? But it consumes more power, and it also requires a cooling mechanism due to heat generation. You might notice in your laptop, even though there is a fan, but if you put it on the table, it will get heated. So for what? So what we use this type of stand. I was trying to show you, but not possible. Just to give me my screen is locked. Just give me a second. Just give me a second. Just a minute. I was trying to show you the laptop stand of mine, but my tablet screen get close. Okay, so my voice is fine. This we have cover. Okay,
Yes,
so
sir.
this Yes, yes, fine, 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 fine. I have heard that my voice is coming. Thank you for your cooperation. So now we talk about the cost. Of course, the cost of microprocessor is high because it is a general purpose microprocessor and it is having lot and lot of capability as compared to microcontroller. So the cost you have to pay, which is high as compared to microcontroller. Cost of the microcontroller is less because all the components are integrated in a single chip, right? Now we talk about the programming complexity. Microprocessor understand only the language of 0, 1, but it is very difficult for us to program in the form of 0, 1. So we have developed a language which is called the assembly language. We do programming in the assembly language for microprocessor, and there is a assembler which convert this assembly language to a language understood by the microprocessor. So programming is little bit typical in nature and complex. It doesn't support the programming in high level language like C and all, right? Whereas microcontroller programming is very simple, right? It is like C. It is like C. Now I'll also show you the. It is also show you the. I'll also show you the some microcontroller, but in very quick way because I think I have only 13 minutes left. Microcontroller, right? This 8 megatel. That is my name is at mega 8, and it execution is quite good but not very fast. It can execute 1 MIPS, that is the 1 mega instruction per second per megahertz, right? It also supports the parallelism, means it can process the various Simon instruction, of course, one by one, but request from peripheral and all devices parallelly. Instruction in program memory are very fastly executed because this supports the pipelining. Pipelining is the process when one instruction is executed, other one is see there are various stages. First you have to fetch, then you have to decode, then you have to execute it. So this process is in pipelining. It supports the pipelining. That is why the execution is fast. So features of this Atmega Tel is this is very high performance, low power, and this is 8-bit microcontroller, advanced version. This is 16-bit um, mega millions instruction per second. It is the throughput at the 16 megahertz. Means you can say 1 MIPS speed you will get, means 1 million instruction per second it can execute. 16 MIPS, I'm sorry, 1 MIPS per megahertz. 16 mega instruction, million instruction per second at 16 megahertz. So in 1 megahertz it can execute 1 million instruction. It has 8 32-bit registers and 3 PWM channels. The two type of package is available in this microcontroller category. One is 28-lit PDIP and other one is 32-lit TQ. Plastic dual inline packaging. Right. If we talk about the memory segment, it is non-volatile memory. Means once you written microprocessor, microcontroller, not you have to written each and every time. It has 18 kilobytes in system self programmable flash memory, which you wish to write, you can not write, because it is the written by the programmer, whereas it has erasable programmable read only memory as well, which is the EPROM. You can erase it electrically. Static random access memory, that is called SRAM. Uh, it has a write and erase cycle somewhere around 10,000 times you can write, and 1 lakhs times you can use in the EPROM, that is erasable programmable read-only memory, means 1 lakhs times you can erase the EPROM, right? And if you talk about the data retention rate, you can hold data in it 20 years at the 85 degrees centigrade. But the temperature is, if the temperature is normal, you can hold it for 100 years. If you load this, you can forget all throughout your life if you maintain the temperature somewhere around 25 degree, right? So it is also having two 8-bit timer and 16-bit timer counter as well, one 16-bit and two 8-bit counter. It is having three PWM channel it is having, and eight analog to digital converter, means analog channel it is having. All right. Then as the time is moving very fast, so I'm not going to detail, but I'll also wish to tell some brief description of the pins. You can see here we have three different port. As I said, three ports are available. So these ports are port B, port C, and port D. These ports are port B, port C, and port D. You can see the numbering of this: PC0 at pin number 23, PC1 at 24, so on and so forth. PC1 to PC5, one set, and then reset and PC6 is at once. Some students, some participant may have doubt why it is so, why it is not like starting from PC0 to PC5. It is made by the manufacturer and it is designed in such a way that the size must be compact. On the basis of this, it is made, not on the basis of your remembrance. That is why it is so. Similarly, you can see there is 8-bit port PD0 to PD8, and similarly for port B. So there are three registers are associated with every port. These are DDR, pin, and port. DDR is the data direction register, whereas pin X means, see, X could be B, C, D. Means if it is pin B, pin C, pin PC0, PC1, so on and so forth, those are the port input. X is you can use as the subscript, which can be used to tell which port it is. It is B. If it is B, it would be pertain to port B. If it is C, then it pertain to C, so on and so forth. Similarly, there is port out. Now I'll wish to talk. I'm skipping all this slide. I'm skipping all this slide. Now the next processor is Atmega 328 processor. This is very high performance, lower power AVR 8-bit microcontroller. Then it processes instruction, manages input, output, all the basic things it does. Then the frequency where you have noticed that was the 16 megahertz, but now it is upgraded to 20 megahertz. It is with 20 megahertz with external crystal oscillator. See, if the frequency is high, what it means? It means the processing speed is fast, because as I told you, each microprocessor or microcontroller is clock driven machine. If it is a clock driven machine, to execute, there are several type of cycle: read cycle, write cycle, interrupt cycle, opcode fetch cycle. Each cycle requires certain machine cycle. Each instruction is required, I'm sorry, each instruction is required certain machine cycle, and each machine cycle requires certain T state, 3 to 4, and or sometime it is 5. And these T state is the uh, time period. Each T state is the time period, and that time period is 1 upon this clock frequency. So if the clock frequency is high, T state is less. If the T state is less, means time required to execute particular instruction is less. The processor is fast. So frequency is high, means processor is fast. You might notice while you are going to purchase your laptop or tablet that they ask which processor you required. You said i3, i7, or i7. Then they ask which generation or which frequency you want. If you go for higher frequency, then the cost of same i3 or i5 processor goes increase with the increase of frequency. The reason is this: because the frequency increase, processing would be fast. Now it has 32 kilobyte of flash memory. Static RAM is now increased from 1 to 2 kilobyte, and EPROM is again 1 kilobyte. If we talk about the peripheral, it has 16 digital input output pin. 14 IOS pins are available. In the previous IC, that was at Mega 8, only 3 PWM channels were there. Now we have 6 PWM channel we have. If we talk about the analog channel, we have 8 analog channel with this. 3 timer are available in this. It can also handle the external interrupt. Means you can interrupt the main course of this processor by interrupting INT0 and INT1. If we talk about the power specification, its operating voltage is 1.8 volt to 5.5 volt. And the power consumption is very, very low. It draw somewhere around zero point 0.2 milliampere at 1 megahertz and 1.8 volt at power save option. So 1.8 multiplied by zero point 0.2, that much power is required by this. And in sleep mode, it draws only 0.1 microampere current. Ampere current is the reflection of consuming power. If the ampere current is low, then the power rating is very, very low. Right? It is also having the watchdog timer. This watchdog timer is keep on the seeing that is that any instruction is going wrong or some malfunctioning is going down. If it is done, then that watchdog timer stop the process. So that facility is available in this, and the temperature range is minus 40 degree to 85 degrees. So you can operate this either in Kullu Manali or in the city like Kanpur or Chennai where too much hot is there. Right? So as the time is 12:29 and the talk was up to 12:30, uh, the conclusion is in this talk we have studies various electronics components which are used in robotics. We try to have the glimpse on various microprocessor, microcontroller, and also see the what are the difference between the microprocessor and microcontroller. So this is my contact detail. I also have one YouTube channel, Power Electronics by Dr. Sanjiv sir. This I started when during the period of pandemic Corona. Whatever the lecture I used to take in various NITs or various university colleges, I put it here. If you feel that it is useful for you, there are so many MATLAB related lectures are there. If you feel, you can go and check this uh, lectures. Right? So if you have any query, you can ask me. It's 12:30. My time is up and over.
You can ask your doubts by raising your hands.
See, there are two possibilities. One is I am too good that I haven't left any unanswered question, or your all doubts are clear after having my talk. That is the first possibility. And the second possibility is you couldn't understand even a single word. So once you don't understand anything, you don't have any doubt or any question. If it is first possibility, I am more than happy. If it is second one, that is not good for me. I can see so many thumbs ups are there. I don't know whether it is somebody is writing yes sir first one. That means there is no doubt. But see, this thumbs up means ठेंगा कुछ नहीं समझ में आया नल्ले or it is good. So I wish even if at present it might be possible as the topic is new, you won't have that much expertise or understanding in the subject. लेकिन even if you have any doubt, you can ask me during the your hands-on session. I'll have my class in final year electric drive from 220 to 310. So during except that time, I'll available with you. No problem at all.
As we conclude today's session, I would like to extend my heartfelt gratitude to Professor Dr. Sanjiv Kumar sir for sharing his invaluable expertise with us today. The session has been incredibly insightful and we truly thankful for the time and effort you dedicated to helping us deepen our understanding. Thank you once again, sir. I would like to remind everyone that our next session will begin at 2 p.m. Please ensure you are back on time and we can make most of the upcoming discussions. Thank you all for your attention and engagement, and we look forward for seeing you in the next session. Enjoy your break.
Thank you, Nati. Thank you. Love you all. खूब खुश रहो सब लोग. Bye bye. Take care.